to the, I guess I get formally started. Welcome again to the Pinal Geology and Mineral Museum and Pinal Geology Mineral, Geology Mineral, and Mineral. Let me try this again. I know where I am. It's been an interesting day. Okay, so welcome to the Pinal Geology and Mineral Museum and Pinal Geology and Mineral Society's monthly meeting. This is our December meeting for 2021. We will be back again on September. I'm having problems with my dates. We will be back again on January 19th. Here we go. Next meeting, probably here. A lot of our members and people who want to come to the meetings are vulnerable people to the virus, and so we are keep holding them online for the foreseeable future. Our speaker tonight is Dr. Michael Conway, and he is one of the research scientists senior research scientist. Is that correct?
Yeah, it is.
With the Arizona Geological Survey, and he's going to give us an introduction to the survey and what some of the resources they have are. And I will let him, he is a geologist par excellence, as well as a cool guy. And I thank him very much for being here. I'll thank him again at the end. But I'm going to turn it over to you. Okay. You just let me know when you want your slideshow up, and I will do that.
Is it? I see it. Is it not up?
Can
others not see it yet?
I see the window, but not the slideshow itself.
Oh, well, that's fascinating. You see the window. I'm not sure then what's going on. I have. Hang on. Let me do this. Let me pull this back and see if that's. Oh, I apologize. I thought everything was already up and operational. So I'm going to have to go back and pull this over here. Hang on.
Here, I'm going to add it to the stream so you can see what's going on my screen.
Okay, well that'll probably help. Because right now I'm kind of running blind.
Yeah.
And I apologize. I thought I was already showing everything.
No problems.
All right. So what are you seeing now?
I am seeing a window with 5 screens.
Okay. Well, let me just start that then. Hang on. And I'll just go into slideshow from beginning. Well, okay. Okay, let's try that again. I apologize to everybody. I thought we were good to go. How about now?
Hasn't changed.
Well, that's fascinating because all I see is my presentation.
I see it says Arizona Geological Survey. Now, what did you share when you shared?
I shared the window on the left-hand side, I guess. What window is it that you see? Do you see a rack of 5 or 6 slides?
Yeah, 6, 9.
No.
They're
okay, but
below.
You see that. Well, interestingly enough, when I go ahead and play it, you don't see that. I'm going to try it again. I think I see exactly what you see.
I see, the first slide's AZGS with
now do you see?
I see the big slide, and the little slides.
Okay, I'll tell you what, instead of messing around with this, I will just do this, and I can just fall down through the slides this way.
Works.
It's going to work for you.
Works for me.
Okay, well, let's go then. All right. Hey, I apologize for the issues, everybody that is listening, and I hope you're all having a good evening. I'm Mike Conway, and I've been with the Arizona Geological Survey since 2007. So it's been a handful of years. I do a variety of tasks for the survey, including outreach and information to the general public. Tonight's presentation, I'm really just going to talk about the resources that we have that are available to everyone. And by everyone, I do mean anybody who has access to an internet connection to websites can get our materials and download them directly. I'll be talking about the resources that we've been putting together between 1915 and the present, but I do want to emphasize that the Arizona Geological Survey has been Arizona's has been the Earth Science Agency for the Arizona Territory and the state of Arizona since 1887. We trace our roots back to the territorial geologist of 1887. Please, if you have any questions, put them in the chat. Bob, maybe one thing you can do is put my email in the chat, and people are welcome to email me directly, either now or later after the event, and I'll be happy to address any questions that you have. Okay, the Arizona Geological Survey, one of the things that we try to emphasize is that we're putting geoscience to work for Arizona. We do this in a variety of different ways. Tonight's talk is really going to focus on Arizona mineral resources, metals, and industrial minerals that we've been building a library of resources since 1915. Protecting Arizona, looking at geologic hazard assessment. We began that in the 1980s, and now it's one of our focus areas. And then how we serve our stakeholders via outreach and information. So those are the three main elements of the talk. All right. Oops. Bob, do you see something just pop up on my screen? Hello?
I'm sorry, I forgot to unmute myself. I see Arizona Mineral Resources.
Okay, very good. I just had a Twitter note pop up on my screen. Apparently, that's usually I've deactivated, but I forgot tonight. So, yeah. So Arizona Mineral Resources, we have been really Arizona's chief agency looking at mineral resources since the early part of the 20th century. We do mineral assessments of public lands, and we take that information, we provide it to decision makers, to your legislators, community leaders, people in the mineral industry, so that they have the information they need to make wise and prudent decisions. We engage with Arizona's mineral industry. We frequently publish materials that are of interest to them, and we get a lot of requests from people in the mineral industry for resources that we have, or in some cases, resources we don't have that they would like us to acquire. Always a bit of an issue there because we have, as you might imagine, limited financial resources. We place all of our materials in online publications and mining repositories that are available to the public, to decision makers, to the metal industry, to everyone, 24/7, 365 days. It's not required that you register to offload material. There's no charge, there's no fee. We don't keep data on you. It's just there for you to pull down when and if you need those materials. And we'll be going through some of that tonight, so you'll know where those resources are located. And we also do a lot of geologic mapping and resource assessment. And these photographs or these images that you see sort of illustrate that. There's a cover of a paper John Spencer did recently on an area in south central Arizona that was being reviewed as a possible national monument. Then there's a geologic map in the center. That particular map is used by the industrial minerals industry because it has a lot of information about sand and gravel. And if you think that's a trivial issue, you would be wrong. Here in the state of Arizona, our number one product, mineral product, is copper, of course. It's huge. Number two is sand and gravel, and that's probably typical across most of America. If you want to build buildings, if you want to build infrastructure, you want to build roads and bridges, you got to have sand and gravel. And we do, fortunately, have a lot of it. And then over here on the right-hand side, oh, that's probably Joe Cook or maybe Brian Goatee doing some work in the field. We have a number, we have 6, 7, 8 geologists now, I think, and they get out into the field and do a lot of geologic mapping, look at a lot of rocks, look at a lot of mineral deposits, those sorts of things. Here at the bottom of the screen, at least I see it clearly, are 3 URLs. The first is azgs.arizona.edu. That's our portal page, that's our home page for a lot of our material. The second one is the repository.azgs.az.gov, and that is where we have posted and placed all of our publications published between 1915 and 2021, and we'll soon be publishing our first papers in 2022. So everything we publish goes up there. And the last one is the minedata.azgs.az.gov, and that is our mining repository, where we have more than 16,000 largely otherwise unpublished mine reports and mine maps. It's a wealth of information. Okay, in terms of our role, the role of the Geological Survey in mineral resources, down here on the left-hand side, it says Geo Mapping. That means we go out, our scientists go out, and they map what they see, typically at the 1 to 24,000 scale. So we've produced hundreds and hundreds of maps for the state of Arizona at that scale, and we'll continue to do that. We publish 6 or 7 new quadrangle maps each year. And then we basically put information into text form, such as our Geology and Mineral Resources of Arizona, 300-page document with lots of information about the mineral resources that that we knew about at the time, and that was back in 1969. So of course we have a lot more updated information. We've always been involved in indexing mining properties across the state of Arizona, and on the right-hand side of the slide you see that cover page. And something we've been doing since Carson Richardson joined us is putting together a directory of active mines in Arizona. The particular cover you're seeing, that was from 2019. We have a 2020 edition, and he'll be putting out 2021 shortly. That is accompanied by an online map service so that you can plug into the map service. You can look for a specific commodity. It might be a metal, it might be sand and gravel, it might be cinders, it could be gypsum. Whatever you were looking for, you could go to that map, pull up just those commodities and where they exist, and get information about where the active mining is in the state. It's a really nice tool. And just to give you a sense of what's involved in terms of the geologic mapping that we do, an individual quad, a 7.5-minute quad, which is about 7 miles by 8 miles, costs about $80,000. Now, fortunately, we have the United States Geological Survey has a state map program that provides states with matches up to 50% of the work that we're doing. So each year we apply for funds so that we can map another 6 or 7 quadrangles, and we put that data out. This is a geologic map. It's really a technical document. If you had no background in geology, you'd probably find it hard put to understand this, but for the geologic community, this is a basic tool that we use. We put out a map plate in a PDF form. We also put these into a geographic information system so that the professionals who use the GIS don't just get this map, they get the underlying databases. Those are available to them and they're available to you. You could download the GIS database as well. If you had no experience with GIS, it wouldn't do you much good. But if you're working on GIS, all of that data is there. So they're extraordinarily valuable products from the survey. Oh, I'm going to hit you up a little bit with information about the document repository. All of our pubs between 1915 and 2021 are there. So that includes hundreds of geologic maps, 500 plus open file reports, 200 bulletins, and hundreds of contributed maps and reports. And the GIS databases that accompany our digital geologic map series. The URL is right down here at the bottom. It's the repository.azgs.az.gov. If you are looking for geologic information for the state of Arizona, that's a fine place to start. I will warn you, most of the materials that you're going to find at our repository are geotechnical materials. That is, they were written for an audience with a geologic background. But we do have a lot of outreach products there as well. Our Down to Earth series are easy to read, 30 to 40 page publications, well illustrated, that we really do build for the purposes of sharing the Arizona geology with the general public.
And that
go ahead.
That URL, repository URL, is now in the description of the video.
Oh, very good, excellent. And something I'll point out
with Mike's address.
Excellent. And something I will point out that's probably not of great interest to most of you, but we mirror this repository over at the University of Arizona Library System, so that if anything were to happen to our document repository, there's a mirror image of it at another secure location that could be brought right back up. And I can't tell you how critical it is to build that redundancy into these repositories. And our historic mine data of Arizona. We launched this in 2013. Some of you may remember the old Arizona Department of Mines and Mineral Resources. They lost their funding. They were state agency, and their funding ran out and was not provided thereafter in 2011. And their documents that they had been acquiring over this pace of 70 years came to the Arizona Geological Survey. The mineral collection, which was over 20,000 minerals, went to the Arizona Historical Society, but has since been returned to or transferred to the University of Arizona, and they hope to open up the museum in Phoenix at some point in time. This is where you want to go if you're looking for information about mining data. We have over 16, well, let's see, I think the next slide actually explains that. Yeah. This is just a little infographic here, trying to provide you a sense of what's at the mining data repository. There are 20,800 objects there, 6,800 maps, 8,500 reports, 5,500 photos, and over 400,000 pages and documents. That's a lot of stuff. These are materials that were handed off to the old Arizona Department of Mines and Mineral Resources, or donated to them by geologists who've been working in this state and across the world for a long period of time. This is an invaluable resource. And just to give you a sense of that, our stakeholders believe that this is one of the most important things that we do, is to make this available. All of these materials, again, they're online and they're available for you to go and draw them down. And they're at the URL is the minedata.azgs.arizona.edu. Now, the physical mining archive that stands behind this is being transferred probably in January of 2022 to the Arizona Historical Society. We were very concerned about preserving the physical archive. We didn't have the resources here at the survey to do that. The Historical Society stepped forward and said, if you'll help us with the transfer, we'll go ahead and take these materials and make sure that they remain available to the public and to others. So that assures their preservation and their accessibility. That's a huge and important thing. The user audience for both our mining data and our document repository is pretty broad. It includes mining consultants, exploration geologists, mining firms, mining archaeologists, environmental firms, the public, historians and science societies, consultants, State and federal land agencies use our resources quite frequently, and I've tried to picture some of those people here, as you can see in this illustration. So we have a large and broad user audience, and we see downloads of some of our most popular products in tens of thousands of downloads. So we've been really successful with this. It's hard to, maybe it's hard for some of you to imagine, not for me. If you had asked us before 2010 for any one of our publications, I would have said, sure, come on down to our office on Congress Street and you can buy a copy of it for $3.50 or $8, whatever it was. But we couldn't provide it to you in any other format. Now, everything that we used to do, we required you to come to our offices, you can now download online. Oh, and this is the last of my mineral slides, and I just want to point out something. Some of you may know Dave Briggs. He's an Arizona geologist for many, many years, worked in many different ore deposits across the state. And in the past 10 years or so, or yeah, about the past decade, he's been getting involved in writing up and documenting Arizona mining histories. All of his materials are online at the document repository. The illustration on the right-hand side, probably, excuse me, his most popular document is the history of the Verde Mining District, Jerome, Arizona. There's a technical aspect to some of these reports. However, many of them are quite readable, quite legible for people who don't have a strong geology background. So if you're interested in the mining history of various locales in Arizona, I'd certainly recommend this to you. His publications range from very short, 10 or 12 pages, to longer, 80 or 90 pages. He's working on a publication we hope to publish in January 2022. That is the history of the Globe Miami District, and that's going to be about 200 pages long, and it's going to have lots and lots of information about the people and the communities that were in the Globe Miami area during the mining there. It'll be a great publication. Okay, I got a blank slide just to remind me that I'm moving on. In the 1980s, the survey made several changes. First, we left the University of Arizona to become a state agency with the state of Arizona. And secondly, we began to we moved away a little bit from mineral and geologic assessments to geohazards assessment. With the increasing population here in the state of Arizona, people are constantly now encroaching on areas where geohazards exist, where things like landslides and earthquakes and earth fissures occur. And we found it very important, and I think our legislature agrees, that we need to do more and more to communicate those hazards to people, to inform them where they occur, why they occur, and how you might mitigate those and protect yourself. So I threw a couple of slides here, and I've got a series of slides coming up. On the left-hand side, and I'll talk about this in a moment, earth fissures and subsidence. In the center, that's one of our earthquake maps. We have a broadband seismic network of 15 seismometers. So we monitor earthquake activity in the state of Arizona, and landslide inventories. Joe Cook and Ann Uberg took the lead. Joe Cook, Brian Goatee, and several others in June 2017 published the Arizona Landslide Inventory. And we went from having a map with a couple dozen landslides on it to having a map feature that we serve online that has thousands of landslide deposits on it. That tells us a lot about where landslides have occurred in the past and where they may occur in the future. So it's a really important resource to have. Okay, the focus on geohazards. What we had to do was beef up our staff, our expertise. We have the publishing platform. We are a publishing house. We publish our own materials. The Geoscience Network, i.e. working with others across the state at Northern Arizona University, Arizona State, and the University of Arizona to communicate with those folks, their geoscientists who are interested in hazards, so that we can all keep abreast of what we know about geologic hazards in the state so that we can inform legislators, the decision makers, the public, communities, and anyone else who needs to know about these sorts of things. And of course, we have to draw down financial resources to do geohazard assessment. The state of Arizona provides us with some money, but it's not enough to really manage all of the geohazard work that we need to do. So we go out and we seek out external grants. Very often, some of them are state grants, but very frequently they're federal grants. So we get money from the Federal Emergency Management Agency. We get money from the Bureau of Reclamation, from the United States Geological Survey, from the Department of Energy. We go out and we get these funds so that we can do these geohazard assessments and provide you with the information that you need to make decisions regarding where you live and the types of hazards that may be in your vicinity. Down here at the bottom, excuse me, I'm talking pretty fast, I suspect. Just some, excuse me, says some logos of our partners. And I apologize for the coughing. If up to this minute in your lives you've not been able to say you've known somebody who's had COVID, you can say it now. I'm just finishing up a breakthrough experience with COVID. Fully vaccinated, and I got it, and I didn't have to be hospitalized by any means, but it was a rugged 2 weeks. Okay, some of the geologic hazards, a little illustration here just to give you a sense of the kinds of things that we look at. Post-wildfire debris flows have been in the news a lot in the last several years, largely because of the mega fires that have been happening in the Western United States, and I'm sure you're all familiar with that. And in our case here in Arizona, the mega fire season seems to be occurring just before the monsoon season. So we have these tremendous fires that destroy woodlands and destroy soils. And then we have the monsoon season, which generates floods, flash floods, and debris flows, as well as landslides. So we're looking at all of these hazards that you see on the right-hand side, all the way from floods and flash floods down to problem soils, which I starred there. You probably aren't terribly familiar with shrink and swell soils, but they are a real nuisance, cause a lot of damage across the United States. You'll probably see the volcanism there, and you may be wondering, oh, gee, what's the likelihood of volcanic hazards in Arizona? Not great. However, it is interesting to note that we have 3 active volcanic fields in the state of Arizona. The Uinkaret field, which is on the north rim of Grand Canyon, the San Francisco volcanic field just outside of Flagstaff, Arizona, and the Pinacate volcanic field on the U.S.-Mexico, on the Arizona-Mexico border. So those are 3 fields where we anticipate there will be future eruptions. Fortunately, the repose period, that is the time between eruptions, typically in these small basaltic volcanic fields, is 1,000 to 2,000 to 3,000 or 4,000 years. So you don't get a lot of eruptions. When they come, they do kind of create some havoc. And of course, the last eruption would have been Sunset Crater about, just under 1,000 years before the present. And it actually did impact the Native American community that was living in the vicinity of Sunset Crater just outside of Flagstaff. Okay, geoscience at work for Arizona. On the right-hand side, you'll see a rack of images. Those are the images you'll see if you go to the Center for Natural Hazards at our website, the website being the AZGS.arizona.edu. Each one of these in the grid has page or 3 or 4 or 5 pages behind it. So if you're interested in earth fissures and ground subsidence, you would select that, and there would be a lot more information that would come up for you. And let's see, what do we have? Floods, problem soils, landslides, and debris flows, volcanism, earthquakes, radon. Many of you may not realize, and radon is not a great issue. It's not a real problem here in the state of Arizona, but there are a handful of select locations, the granite dells up by Prescott being the most notable of them, where there is a relatively high radon concentration that people have to be aware of when they're building. And FYI, radon is the second leading cause of lung cancer here in the United States. Of course, cigarettes being the leading cause. Okay, Natural Hazards in Arizona Viewer. This is an online interactive map viewer that we built with in collaboration with the Department of Emergency Management here in the state of Arizona. And it has 5 or 6 different hazard themes there. You can select the theme of interest to you. And as you see on the left-hand side, if you selected landslides, up would pop this map. It's an interactive map. So you could zoom into an area of interest and you could use the cursor to select one of these features and up would pop some information about that particular feature. It may not look like it, but there are over 6,000 landslide, or excuse me, there are about 4,000 landslide deposits here and another 1,500 to 2,000 debris flow deposits here. So there's a lot of information in the last several years about where landslides occur, and that's useful for the county emergency managers. It's useful for land managers. They have this information in hand. They know what they're looking for and where landslides are likely to occur. On the right-hand side is our earthquake epicenters. Our catalog ranges from 1852 to the present. We're adding new information all the time. There are over 3,500 events, earthquake events, on the map. And Jerry is a geologist, and she manages our earthquake, our broadband seismic network, and she manages the information or the data that goes into this page. It's updated whenever there's another earthquake recorded in the state of Arizona or immediately adjacent, we update this map. You can go in there and you can take a look. Again, this is interactive. You select one of the spheres, up will pop information about the magnitude of the event, the timing of the event, was there any damage, that sort of thing. So these are invaluable resources. And if you look up here, I'm going to move my cursor across it. You can say, it says find address or place. If you're interested in what hazards may be near to you, type your address in and up should pop some information about the type of hazards that you might face. It's really been a great tool and a lot of use. And this is just a quick slide. There's not a lot of detail here, but I imagine many of you have been on I-17 traveling between, say, Black Canyon City or Phoenix or Black Canyon City and Flagstaff, and you've probably stopped at the Sunset Point Vista and looked over at the mountains on the horizon. Right there, actually at the edge of the vista, is a landslide scarp. And all of this material, and I'm going to throw my cursor around this, all of this material is a landslide mass. Probably multiple collapse over a relatively long period of time. This landslide scarp still concerns us a little bit. The rock here is pretty weak, and we would anticipate there could be future collapses along this. So we sort of keep an eye on that. Joe Cook and Brian Goatee of our two geologists spent a field season going up and down I-17, documenting where all the landslide scarps are along that highway to assist ADOT, the Arizona Department of Transportation, in their efforts to spend $300 and some million to refurbish that roadside and to clean it up and make it a little bit more effective, a little more efficient. Knowing where the landslides had occurred and were likely could occur again was a pretty important factor. And we do have earthquakes here in Arizona, and we get that question every time we get an earthquake. People call us and email and say, hey, do we have earthquakes in Arizona? And the news media reach out to us. We do. We probably have within the state maybe 50 to 100 events annually. So each year, Very rarely are they felt. Maybe 1 or 2 a year are felt earthquakes. The rest of them are below that magnitude 2.5 threshold where you can actually feel it. Our seismometers, however, will pick those up, and we can record and monitor all magnitude 2.5 and greater earthquakes that occur in the state of Arizona. And each year, just to keep people informed and to get people sort of to think about earthquakes and what to do in the event of ground shaking, we participate in the Great Arizona Shakeout, a simple exercise: drop, cover, and hold on in the event of ground shaking. And if you're traveling to California, and many of you do, I'm sure, or Nevada or Utah, they get more earthquakes than we do. Knowing what to do in the event of a ground shaking is pretty important.
I can second that. Being from California, and the last place I lived was on the San Andreas Fault, so literally about 2 miles away. And it's important information to know because our building standards here in Arizona are not up to California standards, for instance, where they can withstand earthquakes. You really need to know what to do on the off chance that you'll live through something larger.
That's right. And Yuma actually has the building standards in Yuma, which feels 1 or 2 earthquakes every year, and gets, they're only 50 miles from the San Andreas and the Imperial Fault splay off the San Andreas. So they build accordingly there as well. But you're absolutely right. And we have all of our old communities. We have a lot of unreinforced masonry buildings that these are brick buildings or concrete buildings that are unreinforced. They don't do well when the ground shakes. And we have to be really aware of that situation. Oh, over here on the right-hand side, the person in the big floppy hat, that's Jerry Young Ben-Horan. She's our earthquake geologist and in charge of our broadband seismic network. And I think I took this shot back in 2014 when we went to Duncan, Arizona, over on the, it's easternmost, almost southeastern, but easternmost Arizona. They had a magnitude 5.3 event, which was the first time they'd had an event of that size since the 1930s. Community there, they didn't recall that they'd had that they'd have larger or moderate earthquakes in the past. So it was a real wake-up call for them. Over here on the left-hand side, we have at the repository our booklet. It's 44 pages, illustrated, written for the public. Arizona is earthquake country. Tells you a lot about where the faults are in Arizona, why earthquakes occur, and why they will continue to occur. They're not going to stop anytime soon. We have a YouTube channel at the survey, and we have several hundred, I'm going to say almost 200 individual videos there. I'm just pointing out today, I think, some of our hazard videos. So we've been building out short videos. They're only 5 or 6 minutes long on some of the major faults in Arizona, where they occur, and what's likely to happen if they were to rupture along the length of the fault. We could get a magnitude 7 earthquakes, which are big earthquakes and would be very big for us here in Arizona. So if you want to go take a look at our YouTube channel, there's a whole lot of stuff up there. As I said, almost 200 different videos, I think, and maybe a dozen or so that involve earthquakes. Some of you may be familiar with Karst. If you're from Florida or Indiana or Illinois, you may be familiar with the term Karst. It refers to topography that is formed in part by the dissolution of soluble rocks. And a soluble rock would be rock salt. All right? There are layers of rock salt in the subsurface in different parts of the country. And of course, they add a little bit of water and they begin to dissolve. Limestone occurs in broader, larger areas. It's soluble and it can be dissolved. When that happens, you get caves forming, you get sinkholes, sinking streams, things of that sort. We have karst features in northern Arizona, quite a few, And we have some here in southern Arizona as well. Perhaps the one that is most prominent that you may know about is Karstner Cavern. That is a karst feature, right? That's the dissolution of that limestone exposed in the Whetstone Mountains. Up in Sedona, there's a number of sinkholes up there. These are things that where in the subsurface, in this case, it's the Supai Formation, I believe. Nope, I'm going to say I take it back. It's the Red Wall Formation at a depth of 300 or 400 feet. It has many caverns in it, paleokarst features, and sometimes there's collapses. The overburden, the rocks on top simply break through that red wall into the caverns. And when that happens, a sinkhole develops. The one that you're looking at here, Paul Lindbergh did a great job documenting the history of that sinkhole. And I think the last activity there was in the 1980s. There's been one more recent sinkhole that formed in the Sedona area in the 1990s. I don't know very much about it. It was on private property, so there isn't much that's known about it. But that area the red wall underlies there. It's a limestone. It's got lots of caverns and cavities. So the potential for sinkhole formation there is, I don't want to say high, but it's higher than it is in other places across the state. And these are the Macaulay sinks. Holbrook or Winslow, I guess we'll point to. Winslow is here 15 miles to the north. Holbrook is over in this direction where my cursor's at. There's a scale right here. These are sinkholes probably into the upper salt deposits in the Supai Formation. They're not very large. They're probably 300 feet across and maybe 100 feet deep. But there's a number of them, and you can see that. The Arizona Department of Water Resources, Brian Conway, uses INSAR data to look at subsidence, that is collapse or sinking of the ground surface. Some of these sinkholes remain active today. They are slowly subsiding. They're not dropping. I'm sure you read some of the stories about Florida sinkholes opening up and swallowing houses. That's not happening here. They're slowly subsiding over time. But it's a neat place to go and see active sinkholes. And in the same area around Holbrook, these are referred to as the cracks. I'm sorry, it's written down there in black and you probably can't read it. There's a number of these in the Kaibab Formation. They crop out in the Kaibab Formation on the Colorado Plateau, typically north and east of Holbrook. So these are remarkable features. More than several years ago now, the USGS had a volunteer who was a spelunker and a climber, and he volunteered to climb down into one of the deeper and longer cracks, and he got down to about 500 feet below the ground surface before he decided that he had gone far enough, and he was coming back out. And as you can imagine, if you get stuck at 500 feet below the surface in one of these tight cracks, you're in a world of hurt and pain. But they're really fascinating features. They are a hazard in a sense that occasionally animals wander into them, and sometimes they find the skeletons of horses and sheep and cows. But most of them are not very accessible to the public, and many of them are on the Navajo Reservation. Okay, that's, not the best way to represent this, but I'm going to talk about earth fissures. Those of you from Pinal County have probably heard about earth fissures because Pinal and Maricopa are the two counties in Arizona where we have the largest number of earth fissures that have caused the greatest number of problems. And the earth fissure image that you see here on the right, this was probably taken in 2006. It's kind of a famous earth fissure. It opened up and there was a horse in a corral right over here, and the horse couldn't get out of the way of the fissure opening up. So the fissure, well, it didn't swallow him. He fell into the fissure, and rescuers came and they spent 14 or 15 hours trying to get him out before he finally expired. So that caused a great deal of attention to earth fissures in Arizona. We do a lot of earth fissure mapping, and we make that information available. Again, it's at the Natural Hazards in Arizona viewer. We also make sure that whenever we publish a new Earth Fissure map or whenever we update a map, we alert the civil authorities, public, contractors, realtors, and lenders so they realize Earth fissures are an ongoing problem. They're continuing to form, and there's been a lot of reactivation. I think my next slide sort of describes that. Okay, a little bit here. Anyway, a little data. By the way, this is in Cochise County where they have, after Pinal, probably the most active number of earth fissures in the state, to the point where there are indeed signs along some highways that say earth fissures possible 25 miles per hour, because the earth fissures can open up suddenly and they can do a lot of damage to the road. Cochise County had like us here in Pima and Pinal County, had a very strong monsoon season. They had a lot of earth fissures reactivated and some new fissures formed. There's over 170 miles of confirmed fissures in the state, 180 miles of reported fissures that we haven't been able to confirm. They're the result of groundwater pumping. Fissures occur where we're farming in the Sonoran Desert, requires groundwater pumping, and pull the groundwater out of the ground to water the crops. The sand grains in the basin floor collapse together, causing the actual floor to subside, truly sink. And as it does so, fractures occur along the edges or the perimeter of that basin. And those are the earth fissures. There are 5 counties impacted yet, and the cost is high, but we don't really have a very good estimate. We know that in terms of mitigating earth fissures along highway systems, I think up in Maricopa County along the 202, costs a couple $100,000 to mitigate a single earth fissure. So they're a problem. And they're an anthropogenic problem. They are caused by human activity. Prior to 1929, we didn't have earth fissures in the state of Arizona. And this is kind of a well-known earth fissure. It's in southern Pinal County. It's more than 2 miles long, and we're not seeing the entire length of it here. This picture was taken, I'm going to say, in 2019. There are 3 people right here. The cursor, the yellow little, there are 3 people standing there. This is the fissure that's opened up in this area. It's just south of Arizona City. And it's dozens and dozens of earth fissures in this area. It's, I pointed out because at 2 miles long, that's a remarkably long fissure. Okay, we're going to finish up by talking a little bit about putting geoscience to work for Arizona, informing the public and industry of the state's geologic character, mineral resources, our geologic hazards. This checklist right here gives you a sense of the nature, the scope of our geologic expertise at the survey. We have environmental geologists. We have individuals who do bedrock mapping, the geologic mapping. We have hazard assessment experts, geoinformatics, because we build all of our systems in a geographic information system. So we can transfer that data to other land agencies, to the exploration community, to the public. We have economic geologists. We've just hired a new one a couple of years ago, Karst Richardson. He's doing a great job. So we're looking back at, we're looking at minerals again in a big way. And of course, we have outreach, education, and communications, which is my role. And there, by the way, is my email address, fmconway@arizona.edu. If you have any questions that don't get answered tonight, or if you have issues that you want to raise, feel free to contact me at that email address. I'm very good about addressing my email very quickly. I'm online all the time doing email. And this picture,
that email is in the description. The email is in the description of the video now, as well as in the comments.
Very good. Thanks, Bob. And this picture on the right by Ted Grusing is Sunset Crater, probably in December or January of a year or 2 ago, maybe 3 years ago. Beautiful. It's up in the San Francisco volcanic field. And all of the hillocks you see here in the background are volcanoes. There's more than 600 volcanoes in the San Francisco field. One of the things we've been doing over the past several years, because we want to do more outreach and we want to communicate to the public, and we want to do that in a way that the information's palatable, is we've been using something that Esri, a group called Esri, and they're the ArcGIS gurus, had put together called story maps. So we have a series called Learning Geology Through Story Maps. These are available online. Some of them are interactive. You can open them up and take a look at them. You really can't add much and you can't draw much more information than the text, but we try and provide tours of different areas in the state. And this one, Dale Nations, who was a very well-known geologist at Northern Arizona University for many, many years, put together this geologic tour of Grand Canyon's Bright Angel Trail. Starts at the top and goes all the way down to the river below. We have a walking tour of Phoenix that we hosted, that we built in 2019. You open that up and you can see some of the geoheritage sites as well as some of the building stone that is incorporated in buildings in Phoenix. Geoheritage of the Flagstaff area, we look at the volcanoes, we look at the museums, we look at some of the archaeology. And the 10 earthquakes, we have a little one called 10 Earthquakes That Rattled Arizona that look just specifically at 10 earthquakes and talk about where they occurred, when they occurred, and the impact they had. All of these are available. I don't think I can see the URL through our website, and that's the AZGS.arizona.edu. That's where all of these are hosted. For those of you who like to read and like to get information from booklets, we have our Down to Earth series. John Beasy, who recently passed away, he was a great guy, probably wrote about 15 or 16. We have like 24 or 25 at this point in time, extending all the way from the Flagstaff area through Oak Creek Canyon, down here in the Tucson area and out to the Chiricahuas. So we have lots of these. They're well illustrated. They're written for the general public. They minimize jargon, and they have lots of great illustrations and images to provide you with some better idea of how the geologic forces and processes that produce the geologic features that we see on the Earth's surface. These are really great. And again, they're all online. They're all free to download. They're typically they're between 30 and 60. I think the longest is a 90-page booklet on the Sky Islands, on the Geologic Islands. Whoops. Just some of the partners and stakeholders that we work with. I'm not going to go through all of these logos, and this isn't all of them by any means, but just to give you a sense that the survey is not, and we're not siloed. We work with other agencies daily. We seek resources, that is financial resources, through external grants from other agencies to work that serves the state of Arizona and serves our constituents, which includes you folks. Okay, questions, but before I do that, this is a magnet. And this is an iron bar, and these people, these guys, probably 1930s maybe, these guys are all hanging on this. And just to show that this guy has steel tip boots, he's hanging from his boots. So that's a pretty powerful magnet. So if you have questions, I'm happy to answer them. Here are two of our major websites, the Mine Data site, the repository, and the other one being, down here, and you can't see it because it's in black, but that would be our portal page. So Bob, I'm happy to take any questions you've got. Let's see what happens.
Okay, I put the question, excuse me, I put the question banner up a couple of times and no one's added any questions, though Kelly Wakefield wants to let anyone know that if you are interested in geological hazards, she has a class at Mesa Community College. It's in person and online, and they use a lot of your resources at the survey.
You know, an interesting thing about the geologic hazard coursework is it's often how people come to geology these days. And really, it got its start back in the 1980s, late 80s, early 90s. There were a couple great textbooks that came out, and most geoscience departments, academic departments now, have a geologic hazard course, and it usually brings in more students than just about any other course they get.
Be a cool course to take. Getting my geology education around San Francisco, I had some of that. That was just everything. Wayne says thank you, and it's very informative. But if there's any other comments, questions, please add them quick so we can have them. And otherwise,
yeah, and people should feel free to email if they think they have a question they don't want to put it up here. They can email me the question. I'd be happy to address it. We get dozens of. We have a service called Ask a Geologist, and we get 2 or 3 requests there each day for information.
Great to know. And you can always email the museum, and if we can't find anything, we can't answer your question. We try and get an answer for you.
Mm-hmm.
So even if we have to ask Mike. All right.
Yeah. Well, you have, I mean, Grant is such a professional and many years experience, and he's Arizona's mineralogist. Mm-hmm. So you have an incredibly invaluable resource in Ray.
Oh yeah, don't I know it? All right. Well, I guess we'll wrap it up. Everybody seems to be silent on the question front. Thank you all for watching. Thank you very much, Mike, for coming and talking to us. I found it very interesting and informative, and I've seen some places that I'm going to go that I didn't know about already on your website. So
okay,
and things to look for.
Though
I use it regularly also, because I'm just a poor biologist lost in the woods here. So, all right. Thank you all for coming. I appreciate it. I'm going to end the broadcast and have a great time. See you on January 19th.
Good night, all. Thanks, Bob.
Thank you.